Hi, my name is Maya, and today we're going to talk about a mass on an oscillating spring. So the purpose of this lab is to predict the motion of a mass on a spring using the energy principle and the momentum principle. So we've worked with the momentum principle before, where in this form I'm using V final is equal to V initial plus net force divided by mass times time. And this is used to update the velocity and the position of mass. And these are essential for tracking the change in energy as the mass oscillates. So we are able to use the data from watching a mass oscillate on a spring just from the position and the length of the spring. And we are able to do some calculations and plug it into the energy principle in order to get the change in energy. So we know that the energy principle is that the energy initial is equal to the energy final, and that in this system, the total change in energy is going to be zero. So everything is going to equal zero. By calculating the spring constant from the tracker video, a computer model should be created that simulates the exact motion of the mass and tracks the energy of the object as time progresses. So the initial conditions of this lab were a 0.402 kilogram mass, and it started roughly around the origin with an initial velocity of 0, and the stretched length of the spring was 0.7 meters. The movement of this mass on the spring as it left rest was recorded using tracker. So some initial calculations that I made after tracking the position versus time, I found the period, which is the time it takes for it to move one circulation, the spring constant, and the initial length. And these are all they're all required for calculating the updated position and for calculating the energy as the mass progresses. So I put these conditions in a glow script where, in order to predict the motion of the mass, we need to use a combination of the momentum principle and the energy principle. The momentum principle updates the velocity and position, and then those values are inserted into the energy principle to plot the change in energy over time. The momentum principle is seen above here, where we have the change in velocity and the change in position. And then our energy principle, where we have our kinetic energy, gravitational potential energy, spring potential energy, and total energy, where the total energy is equal to the sum of those, and then the change in energy is the final total energy minus the initial total energy. So this was the glow script model. In red, we have gravitational potential energy, blue kinetic energy, green spring potential energy, and orange is the total energy. And here we can see that the energy principle is satisfied as this mass oscillates. The orange line is the total energy, and it remains constant at 0. So energy is conserved. There's no random energy being created or destroyed. We're not breaking any physics laws. The energy principle is satisfied. It's just staying constant. And we have our oscillation periods where for the x position and the y position is the time that it takes for it to make one oscillation. So for the x position, I got 1.46 seconds, and the y position, I got 1.52 seconds, which is a difference of about 0.2 seconds. These discrepancies could be caused due to tracking errors. It's very possible that I didn't exactly plot the center of the mass, and it causes a little bit of discrepancy, or because it could have moved like a little bit in the z direction, and that just changed the position a little bit, and it was a little weird, and it makes it not a perfect system. This system is also not a perfectly closed system. While energy is conserved in theory, if the mass was left to oscillate indefinitely, it would eventually stop because of air resistance, and it would just come to rest because energy is lost to the system. And it doesn't mean that the energy principle is violated, it just means that the energy is going somewhere else. It's leaving this system into a new system.